So again, we want to welcome everyone to tonight's webinar. I'm Joe Deli Carpini, the Science and Operations Officer. With me tonight, we have Rodney Chai, one of our meteorologists, and Hayden Frank, one of our lead meteorologists. So we're going to discuss the February 7th winter storm in southern New England. So I will have Hayden start off with a look at kind of what happened and some of the model data as well as some of the radar data. So Hayden, go ahead and take it away.
All right, great. Thank you, Joe. So what we're showing first is the snowfall from this event. And what you'll notice initially is very little snow fell across western Massachusetts, some places a half inch to an inch and a half. That's all they had. And then you'll notice a general swath of 4 to 8 inches of snow across most of the region. But if you look closely, right on I-95, there is an area of basically about 8 to 12 inches of snow. And actually, the foot was right over Joe's area in Norwood. So there was what we call a mesoscale snow band, and we'll talk a little more about that as we go through the presentation. So jumping ahead, this is what we call 500 millibars, but it's basically looking at, say, 18,000 feet off the ground in elevation. So you're thinking of sometimes where airplanes are flying. They often fly higher than that, but it gives you the general idea. And what you'll notice about the we call upper flow, it's more of a west to east. There is like a little component of it going from southwest to northeast. But a lot of times when we get our big coastal storms, you'll see what we call the patterns more amplified. So you see energy digging further south, and you have more of a south to north flow up the east coast. And this is what made this tricky. How close this low would get to the coast? Would it kind of escape to the east, giving the flow wasn't, as we say, backed, as we often see. So that was a look at the GFS model. Here is a look at the actual surface low pressure system, emerging off the Carolina coast and tracking, well east of the Cape and Islands. Is actually, we'll talk about that in the next slide or two. A real good setup for a snowstorm along the Boston to Providence corridor. The one thing we were missing is a strong high pressure system over eastern Canada. And that usually supplies the cold air. It can also help generate strong winds. So when you don't have that high over eastern Canada, you need what we call a thread the needle track, because if it gets too close to you, it's going to be rain. And if it gets too far away, you won't get much of any precipitation. So the low pressure system, when we call the benchmark track, it's basically where you see those two lines cross south of Nantucket there. And that is an ideal track for heavy snow in the Boston to Providence corridor, with lighter snow off to the northwest, and then maybe some mixing issues across the Cape and Islands. Now keep in mind, this is just kind of a generic average. It doesn't always work that way. We've had major snowstorms with a low tracking well south of the benchmark, and we've had significant snows with it tracking up towards the Cape and Islands in the Boston Providence corridor. There's a lot of things that come into play, but this is a general idea of what we usually see for a typical heavy snow situation. It did pan out this time. So looking a little off the surface here, we're about at 2,500 feet, and basically we have a 4-panel here, and this is displaying different models. One is the GFS, one is the NAM, and then on the lower panels, you'll see the European model and the Canadian model. And this is, again, looking at the wind fields. One thing to note is the other models, a lot of the guidance had the strongest winds, offshore, the European, the Canadian, but you'll notice the NAM was closer, and it was correct, and that was the forecast dilemma. And it makes sense. Obviously, the stronger the winds you're blowing, from the northeast, the the farther northwest that is, usually means the heavier precipitation is going to get that much further northwest, and you're going to get heavy snow or rain depending on your temperature profiles. Some of the guidance was not as robust as the NAM, so we'll talk about that a bit more here as we go along. So one of the pieces of data, this is the href model. Basically, it's kind of an ensemble. When we say an ensemble, it has different members, and then you can kind of get an average of it. In this case, this is the individual members. Now, there's different members here. Some of these members can be, at times, a little too heavy with their precipitation, depending on the scenarios, and that's where forecasters have to kind of come in and look at all the data. But you could see they all hit the I-95 corridor fairly hard. Now, some of them actually hit areas even into southern New Hampshire quite hard, which didn't really happen. And all those members were further southeast. So again, it's kind of putting all the data together and looking at, which models handle which situations better. But we really do like the href model, although you don't always want to put all your eggs in one basket either. So another part to a snowfall forecast, and this is a very significant part, it's not just how much precipitation you're going to get. So a lot of times you'll talk about what we call a 10-to-1 ratio. So if you get a half inch of precipitation, that's going to be 5 inches of snow. If you get an inch of precipitation, that's going to be 10 inches of snow. Well, not only do you have to get that part right, but that doesn't necessarily translate over to how much snow you're going to get. And it also doesn't mean that if you're 15 degrees, you're going to have really good snow ratios, where a half inch of precipitation may mean 10 inches of snow. It may only mean 4 or 5 inches of snow, where in certain cases, if you're warmer, you could get higher snowfall ratios, and that's because it's where the snow is being generated. And that's what we call the heavy snow signature. And this is looking at what we call a cross section from Providence. And the green is moisture, and each line there represents about 5,000 feet. So you're going up in the atmosphere. And you notice you see the moisture, and there's also what we call lift. That's indicated in the yellow there, and you have the purple, which is the ideal snow growth area. That's in that -12 to -18 C range. That's ideal for good snow growth ratios. That's where you can get, say, instead of 10-to-1, you could get 15 to 20-to-1, even higher. And that's where you could get, 1, 2, 3 inch per hour snowfall rates, what we saw in this event. So just because temperatures are around freezing doesn't mean you're going to have poor ratios. You can have really good ratios with marginal temperatures. So this is a really good tool here. It's from the href, and it's looking at its ensemble members. So this is going to give you kind of a mean, and it's the probabilities of snowfall rates exceeding 1 inch per hour. And you can see the time on there. This is, we get in the late morning, and then 20Z, that would be, say, 3, 4 in the afternoon. And notice where the heaviest confidence is near and southeast of the I-95 corridor. In reality, it ended up a bit further northwest than that, but it gave you a really good idea. The important thing to keep in mind is this model guidance is basically assuming a 10-to-1 ratio. So even though those highest numbers may be indicated down towards the Cape, you actually may see them further inland. In this case, it was further northwest onto that I-95 corridor. So one thing we also utilize quite a bit is called the National Blend of Models. And what this does is basically kind of takes a bunch of models. We've looked at the ensembles when you're taking, a certain model and tweaking the initial conditions and then seeing the different outcomes. Well, this is taking a bunch of different models, say GFS, the European, the NAM, and then various other models, what we call high resolution models, which tend to be more precise. And it gives you an idea of what, to expect. So this is basically looking at, this was initialized early Saturday. What would be the 10th percentile? And we refer to that as like the least case scenario. Some may refer to it the best case scenario if they don't want snow. But basically, this indicated very little snow across the region, basically nothing. So if the storm ended up passing far enough southeast, we wouldn't have gotten anything. Now, the 50th percentile, this is kind of looking at all the guidance combined and taking the average of it. And a lot of times you'll see this smoothed out. Notice, basically 2 to 3 inches out in northwest Massachusetts, you know, 4 to 6 inches right along the I-95 corridor with slightly lesser amounts to the southeast. Now, keep in mind, this is weighting a bunch of models together. So sometimes it can be too smoothed out. The gradients may not be sharp enough. But what this is hinting at is a significant banding signature near I-95. Notice those higher amounts. So again, it's being kind of weighted out by the lesser models and then the higher models. So you're not getting the full effect of it, but you kind of see a possible telltale sign there. Now, this is what we call the worst case scenario. That is if you don't want snow. And you're indicating areas of a foot, even more of snow. And what you'll see here is it actually hit the max area, but it was over too large of an area. So again, utilizing all the data combined, a lot of times you'll see this worst case scenario indicate way too much snow over a large area, but for a small area, it may be very accurate. In this case, it did a really good job, say near the I-95 corridor where Joe lives, Norwood, Sharon, that area, which was hardest hit. So that's where forecasters can come into play, is like that worst case scenario is probably going to be overdone for a lot of the region, but if there's a banding signature in there, it may be correct for a small area, and that's what we're there to do, and kind of fine tune that information. So just comparing what happened, versus what the MBM was showing. If you look at the 50th percentile, notice it was pretty good for a lot of the area, except Norwood, right? Because that's where we had that mesoscale snow band. But when we looked at the 90th percentile, it was very close to what actually transpired. So, kind of working off the 50th percentile, but then kind of incorporating some worst case scenario data if you can locate where some potential banding may occur. And Rodney's going to talk about that in a little bit with more specifics. So looking at the radar, this is as we approach lunchtime, you can see a band of heavy snow across Connecticut. It kind of initiated itself in the southern Connecticut area and was working into our region. It was lifting northeast. Temperatures were actually above freezing along the coastline, so there was actually some rain at the onset, especially the Cape, but that did flip over to heavy snow there too. And as we go along to the next slide here, you look at the radar in the afternoon, and it's quite evident. So you've got, just light snow across northwest Mass, north central Massachusetts. Then you kind of see a significant area of precipitation, rain changing over to snow in the Cape and Islands. But look at those yellows, basically from near Boston, through Norwood, Sharon, into northwest Rhode Island, and back into northeast Connecticut. It's a narrow band, but it's a band of very intense snow, where some places were 2-3 inch per hour snowfall rates. And on top of that, it wasn't moving too much. There was also a second band near Nantucket, and that's quite common. You'll see one band, and that's being generated more by the surface winds, that convergence, and then you have a band further removed from the northwest, and that's where those mid-level winds, say winds at 10, 15,000 feet, are coming together. And again, we'll talk more about that as we go through the presentation. And again, this is Another way to look at it, using the precipitation type on there, it was fairly accurate at this time. You see really that heavy band from Willimantic into northwest Rhode Island, right into Norfolk County, and into the southern portion of Boston. Actually, the south portion of Boston ended up with significantly higher snow than, say, Logan Airport during this event. That's how narrow this band was, but it was extremely intense. So again, looking at these returns, a lot of times, a good hint, if you start seeing 35 to 40 dBz echoes, that could be 3, even 4 inch per hour snowfall rates when you start to get those type of returns. And this was from Joe, 3.6 inches of snow in the past hour between 1 and 2 p.m. That afternoon. So a great example of a mesoscale narrow snow band. So as we like to look at, we talked about where you usually see these snow bands, something called 700 millibar frontogenesis. And what that is basically a difference in temperature. We're usually thinking when we hear a cold front or warm front, we're thinking of what it is at the ground. Well, a cold front moved through, my temperature dropped from 55 to 35 degrees. Well, this is the same idea, but it's at, say, 10, 15,000 feet, right where the precipitation is being generated. And you can see a lot of times this was from our the mesoanalysis page, which is off the Storm Prediction Center. Notice you see the strongest 700 millibar frontogenesis right across the Cape and Islands. But the heaviest snow is displaced northwest of there. And that's because you have to think of the atmosphere in 3 dimensions, right? So if there's mid-level convergence, that air is being forced up and over. It's usually displaced just northwest of that. So where you see that strongest mid-level frontogenesis at, say, 10,000 feet, that temperature gradient, often the heaviest snow is northwest of that area. And that's exactly what happened in this case. And looking at 925 millibars, note the tight packing at temperatures south of Long Island and Nantucket. That coincides with the second band. So it's quite common in our winter storms to see 2 bands. One's being generated off the surface. Sometimes there could be a coastal front where temperature could differ from, say, 33 degrees to 18 degrees over a very short distance. That can be a focus. And then you have your mid-level frontogenesis band. And sometimes we call in between that, there can be an area that receives a lot less snow, depending on the dynamics of that. And that, if you went down like Plymouth area, that area, they still got 4 to 8 inches, but they got, a lot less than to the northwest. The Cape and Islands would have had over 8 inches to 8, 9, 10, 11 inches, but they had some precipitation type issues at the beginning. So it didn't all cash in as snow down that way. And I think we're going to loop this radar here. And notice how the primary band of heavy snow collapses southeast towards the Cape Cod as the coastal low starts to lift northeast. And what's interesting is this wasn't a particularly strong low pressure system, but a lot of times we get these more stationary snow bands, and it was stationary for a time in that area for several hours. And you often get that with the weaker systems because there's nothing pulling it southeast real quick. Sometimes with the real strong storms, storms are racing and it ends up pulling the band, quickly to the east. In this case, because the storm was relatively weaker, it was able to kind of hang out over that area for, several hours, which is interesting because usually, obviously, if you're thinking a stronger storm, you're thinking more snow, and it can work that way. It often works that way, but sometimes you get these narrow bands in these smaller storms or weaker storms. Okay, so with that, I think I am going to turn it back over to Joe, who's going to talk more about the messaging with this system.
All right. Thanks, Hayden. So we're going to go through and talk about some of the the forecast that we had and kind of how we messaged this event out to the emergency managers and media and the public. So here's a look. This was our Friday morning forecast, so we're a couple of days out. And we like to say this was our first call, snowfall. And you can see on the map, we had the highest totals focused along really the south coast, Cape Cod and the islands, amounts of 3 to 4 inches, and lesser amounts as you head farther inland. So we started Friday morning with our email briefings, which we typically do prior to a significant storm. And those to go out to our federal, state, and local emergency managers. And usually when we're in a situation where there's an offshore storm, like Hayden showed, it was close to the benchmark. Some of the models had it a little bit offshore. We're going to play it conservatively. So we're not going to come right out of the gate showing, 6 to 8 inches, 8 to 10 inches, or even up to a foot. We're typically going to start low, where we're more confident. And then as we get closer to the event, as you'll see on some of these further slides here, we'll start to gradually ramp the amounts up as we start to work on those details, exactly like where's the heavy snow band going to be. But in a lot of cases, like this one, we don't always know where that heavy snow band is going to set up. We have a general idea, but sometimes it's not until it shows up on radar, maybe 3-4 hours ahead of time, that we have an idea where that heavy snow is going to be. And this was certainly one of those cases. It was very, very challenging from a forecasting standpoint. So Friday afternoon, some of the new model guidance had come in, and the day crew put up a winter storm watch along with our neighbors at the New York City office. I went across from the New York City area, Long Island, southern Connecticut, into most of Rhode Island, and then southeast Massachusetts, including the Cape and the islands. And as you can see, at that point, some of the totals were nudged upward a little bit to about 6 to 8 inches for a max along the south coast. And this is based on the track that was probably just a little bit outside of that 40-70 benchmark. So showing more of a glancing blow, more of a favorable track for the south coastal areas at that point. This, again, is Friday afternoon. So then Saturday morning, this was on the overnight shift, the watches were converted to warnings where you see this pink shading across southern Connecticut and pretty much where the watch was initially. So this was the area where we felt we had highest confidence for reaching warning criteria, meaning more than 6 inches of snow. And you could see a watch was expanded further to the northwest, and the snowfall totals were as well. This was an area of lower confidence. Notice we didn't go right to warnings there. So the watch means there's essentially a 50% chance of reaching that 6 inch or greater totals in these areas. So, the forecast problem as well, if the storm starts to track closer to New England, then the heavier snow is going to arrive, make it farther inland. But if it stays the same or moves offshore, then certainly the south coast is going to be impacted. But it seemed more of a lock at this point that the south coastal areas are going to be impacted as opposed to how far inland the snow is going to get. So even though we were showing totals of 6 to 8 inches in Worcester, there certainly was much less confidence than, say, down here in New London or Charlestown or even over toward Providence. Then Saturday afternoon, the models kind of had a little bit more of a northward trend, taking the storm closer to southern New England. I believe it was closer to that 40-70 benchmark. So at that point, there was higher confidence that the heavy snow was going to reach into places like Worcester County and Boston and into northern Connecticut. So these areas were upgraded to warnings, and winter weather advisories were issued for neighboring areas of New Hampshire and also western Massachusetts, northwest Connecticut, where the totals were expected to be a little bit lower. And also the islands were downgraded as well because of, as Hayden mentioned, there were issues with precipitation type starting as rain and then eventually going over to snow. So that was going to hold down totals there. But really at that point, kind of the Boston, Providence, Worcester areas were expected to see the heaviest. But you can also see, which actually turned out to be a pretty good forecast, the heaviest snow was expected from Rhode Island up toward Boston and a band of 8 to 12 inch totals. Now on Sunday morning, and this is called life, we call life on the edge, being on the edge of a storm system. Well, the models trended south a little bit with the stronger lift and the heavier precipitation. So the thing, that is normally done is you trend the forecast a little bit south again. So notice we're kind of where we were Friday afternoon, that the heaviest amounts along the south coast. Warnings were kept up there, but downgraded here into the Boston area, which would make sense with a more offshore track. And It's not always easy. Sometimes the difference of 15 to 20 miles is going to make all the difference in the forecast, and that certainly was the case here. And I can tell you, I've been down this road many times myself, and it's always frustrating and never gets easier. But based on consensus of all the model data and discussions with say the Weather Prediction Center, which is our national center, and our neighboring offices, this was the resulting forecast. So things were trended a little bit south going right into the event, which is kind of disappointing. When I think of it from a model standpoint, you'd hope they kind of get a little be able to fine tune these details a little bit better getting closer to the event. But again, they're models, they're simulations, and they're certainly not perfect. So during the morning, when we get into the beginning of the event here, what our day shift was doing was kind of keeping an eye on, things like on the mesoscale, like Hayden was showing some of those maps earlier, keeping a trends on radar, trends on satellite, kind of see what's going on so we can tweak the forecast as we need to. And in these situations, when there's a threat of heavy snow over a large area, we'll get these mesoscale discussions from the Storm Prediction Center, and very much like the ones we see for tornadoes or severe thunderstorms, this time focused on winter weather. So they had outlined this area here across Long Island into Connecticut, Rhode Island, Eastern Mass, with heavy snow developing maximum rates of 2 to 3 plus inches per hour across parts of southeast New England by 2 to 4 p.m. So this is a good heads up for us, and kind of for everybody that, okay, yeah, things are coming into play here. And again, you can see the axis is a little bit farther south of Boston, but it does edge up into the Boston area. So there is uncertainty as to where that band will set up, but confidence was increasing. It was somewhere within this outlined area here in the blue. So early Sunday afternoon, as things were kind of coming into focus, really clearly based on radar primarily, but also upon, based on spotter reports that many of you provide us. The forecast was updated around midday, and you can see the last forecast here on the right. And this was additional snow from 1 p.m. onward, so it doesn't include the whole scope of the event. But the focus was in Rhode Island, eastern Massachusetts, and Norfolk County into Boston was upgraded into warnings, as well as northern Providence County in Rhode Island, when it was more apparent that obviously this was going to be the area of greatest snowfall. So, in some cases, like I said, when we're on the edge of a storm like this, it's not a slam dunk. We go back to a quote unquote easy storm to forecast, a blizzard in January 4th, 2018. That's kind of a slam dunk. It's going to hit all of the area. But these, when they're passing just off the coast, like I said, the difference of 10, 15 miles can make all the difference with the snowfall forecast. And a lot of times we just won't know until things are unfolding on radar 3 to 6 hours ahead of time in some cases. So this was certainly one of those situations there. So let's take a quick peek at our forecast verification. Again, the Saturday afternoon forecast did pretty well. You can see it on the left compared with the observed. The observed is on the left and the expected is on the right. You can see the main band was picked out pretty nicely between Boston and Providence with totals of about 8 to 12 inches. And again, the Sunday morning forecast shifted things a little bit further south. Not a complete bust, I would say, but, did hit some of these areas to the south, but obviously knocked the totals down to the north a little bit too much. If it wasn't for that band, yeah, there would have been 4 to 6 inches, but it did, kind of sit over that area for a few hours and pumped up the totals to about a foot. So with that, that's a look at our review of the February 7th event. We're going to pause here, and Hayden's going to help me answer some questions, and then Rodney will continue with a look at our weather briefing for the next week or so. So let's see. So from Jonathan, great agenda, guys. I love it, and thank you. Thank you, Jonathan. From Joe, good observation. Frontogenesis has been a common theme this year with winter storms here in southern New England. Absolutely. That's something, it really helps show, like Hayden described, the two bands, mainly the more inland band of heavy snow. We saw that with this one, over greater Boston to Providence. If you remember the December 15th big storm that dumped 40 inches in Binghamton and up into New Hampshire, that was mid-level frontogenesis. So we're trying to teach, we know folks want to learn, and that's one field you want to look at going into all winter storms. Definitely look at the frontogenesis. And from John in Walpole, 8.5 inches from 1 p.m. to 4 p.m. And John, I think that's pretty much exactly what I had in Norwood right next to you. So excellent. Okay, I'm not seeing any other questions.